Hello, I'm Dr. Enzyme. I'm one of DVC's BioSci 102 instructors, and I'll walk you through the first lab in our lab manual, the scientific method. Okay, this isn't actually a true lab. We don't conduct any experiments for this. There isn't really any hands-on work, but this is our super important introduction to all the other labs that we do run. So it's kind of the foundation for everything else we'll be doing in lab. Before you do science, you need to know what good science looks like. So, what is science anyway? Let's start with that. Science is an evidence based approach to understanding the natural world. So, it represents both what we know and how we know it. In other words, science includes all of these facts that we learn in this course and also the method of how we learn them. And how we learn them, that's the scientific method. So, the scientific method is an organized way of offering logical explanations to what we observe and also testing out those explanations. Okay, and we are all scientists. You are already a scientist, just like Beaker and Bunsen here. You're always using the scientific method to figure things out in your everyday life. For example, you get home from work, you flip on the light switch in your living room, and you discover there's no light. Okay? Why? You ask yourself, why is there no light? You have this observation, you make a hypothesis, and you test out your hypothesis. Okay, so maybe you think that the power is out. This is your hypothesis. So maybe you'll walk into the kitchen and try to flip the kitchen light on, and it turns on. Okay, that means you have to revise your hypothesis. It's not that the power is out. Maybe it's the light bulb instead, right? So now you go and you try changing the light bulb in the living room and you find out that it works. You have light, right? So you experimented. You were able to draw some conclusions from your experiment. The point is that you're a scientist already, but let's improve on those skills a little by learning a little more about the scientific method and good experimental design. Oh, and science. What is it good for? Does it have any limitations? I want you to read through this list of questions on your own and think for a minute about which of these you think could be answered with science. So pause the video and read through these. Okay, let's go through them. Number 1, are serial killers evil by nature? So this exact question, as it's currently phrased, probably can't be answered by science, right? Why? Science does not make moral judgments. So when you're looking at this question here, the word evil, it's not the role of science to work through this, right? But maybe you could take this question and rephrase it a little bit. Maybe you could ask instead something like, are serial killers genetically predisposed to lack empathy? This is actually something that science could probably address. Okay, how about number 2? What is the cause of whooping cough? Yeah, for sure. That's something that you can answer with science. It's a question about the natural world that can be investigated using the scientific method. What about number 3? Why is the grass green? Yeah, for sure. That can be answered with science as well. What about number 4? What is the best recipe for chocolate chip cookies? This one's a little bit tricky. This is a subjective question, right? Everyone might have a different idea of what's best. Science tries to be objective, not subjective. So, as this is currently written, this would be difficult to answer with science. But you could rephrase this, right? You could ask something like, which recipe produces the most popular chocolate chip cookies? And that's something that could be answered with the scientific method. I want to point out too one more thing that science doesn't do. It doesn't tell us how to use the information, right? So science, for example, could teach you how to clone your cat, but it doesn't tell you if you should clone your cat. So science does have some limitations. Okay, let's look at the general process of using the scientific method. Overall, it involves questions, explanations, and experiments. And let's look at another practical example for this one. Okay, so in this example, maybe you sit down and you try and turn on the TV with the remote, and oh no, the remote doesn't work. This is your observation. The question you ask from this observation might be, what's wrong with the remote? Then you make some hypothesis for your question. In this case, you think maybe the batteries are dead. Okay, and what is a hypothesis? A hypothesis is a tentative explanation for what you observe. So it's often also referred to as an educated guess. In scientific research, a hypothesis usually has a lot of evidence to back it up. It's not some random guess. Instead, it's the accumulation of all this previously acquired knowledge to try to answer some new question. Okay, so you have this hypothesis. You can make a prediction from this hypothesis. In this case, your prediction is if you change the batteries, the remote will start working. And then finally, you run your experiment. So you change the batteries and you look to see if the remote now works. Okay, and look at the results and draw some conclusions. So you change the batteries and the remote works. Great. It was the batteries, right? The experiment supports the hypothesis. If you change the batteries and the remote still doesn't work, you need to revise this hypothesis. Okay, so let's go back to the hypothesis for a minute and get a little more specific. So there are two types of hypotheses. One is called null, the other is called alternative. A null hypothesis states that there is no difference between groups being studied. Okay, so for example, if you are studying the effects of calcium on bone strength in mice, the null hypothesis in this case would be that there's no difference in bone strength between mice given calcium and mice not given calcium. And the null hypothesis is usually what the researcher is trying to disprove. Okay, so why would we ever need a null hypothesis, or why are we talking about a null hypothesis? This is actually very helpful in some statistics, some statistical analyses, and we'll actually use that and see that later on in this course. And then the other hypothesis is an alternative hypothesis. This states that there is a statistically significant difference between groups. Okay, so if we go back to that example where we're studying the effects of calcium on bone strength, for that example, the alternative hypothesis would be that mice given calcium have an increase in bone strength. Okay, so this is what we traditionally think of as the hypothesis, if we just use the word hypothesis, right? This is our educated guess. It's also referred to as the alternative hypothesis.